Hello friends, welcome to Electrical Design Engineering YouTube channel. This is our lecture number 55 of our free course ETAP. In this lecture, we will see the second case of our motor reacceleration. In the lecture number 54, we have tell you that we will study the three cases. That is, uh, first case was when the fault was cleared after zero point 0.5 seconds. That was discussed in the lecture number 54. And now it is lecture number 55. In this, we will discuss that when the fault is cleared in zero point 0.1 seconds. And second case, we will see that when we have to find the critical fault clearing time, that is the maximum time during which we will clear the fault so that our motors reaccelerate successfully. So, first of all, we are presently in the transit stability mode, and I will go to the edit study case. And clicking on the edit study case, I will go to the events, and in the events I have created this was the first event which was discussed in the lecture number 54. I will show you one thing that I will run the transit stability, that motors are not reaccelerated at zero point 0.5 seconds. This is the plot of transit stability. I will select the bus, and then I will select the voltage, and I will select the buses 7 and 8 on which motors are connected. You can see the voltage is not back to the supply voltage. So finally the motors that does not accelerate, that become halt, they stop finally. I have discussed in detail this case in the lecture number 54. You can watch this lecture also. Now I will decrease my fault clearing time to 0.1 seconds, and then I will see what will be happening. I will change this. I will click the edit here and change this time to 0.1 seconds and click OK. Then click OK and run transit stability. And then I will see the plots of the transit stability. Then I will select the bus, and in the bus I will select the voltage, and here we will select the bus 7 and bus 8 and click on the plot, and you can see now that our motors have successfully reaccelerated. The voltage has gone back to 100%. You can see in percentage also. Now the voltage is back to their original value which was before the fault. Now this was the case second when we have decreased our fault clearing time 0.1 seconds. So that means our motors have reaccelerated successfully. Now we will see another case, that is that to find the critical fault clearing time, that is the maximum fault maximum time to clear the fault so that our motors reaccelerate successfully. This is the hit and trial method. Finding the critical fault clearing time is a hit and trial method. So we have to decrease the fault clearing time. We know that our fault at 0.5 seconds our motors does not reaccelerate. So from that I will decrease the fault clearing time step by step and find at which point our motors will reaccelerate. So for that I will go to the edit study case, and events I will go to the 0.5 second, that one this point, and select the edit, and at this I will first select 0.4 seconds, that is 0.4. After 0.4 seconds we will clear the fault and click OK and run transit stability. And in transit stability I will select here the transit stability plots, and then I will select the buses and select the voltage and click these buses and click plot, and you can see that our motor has not reaccelerated at this voltage, that is at 0.4 seconds. Our motors has not been reaccelerated. So I can close it again. I will decrease it again we will decrease it to 0.3 seconds and click OK, and run transit stability, and then click on the transit stability plots and select the buses and select the voltage, and then select the bus 7 and bus 8 and click plot. Now you can see again the transit stability, our motors has not been reaccelerated. So I will decrease further this time, that is fault clearing time. We will decrease further, we will decrease it further. We will see 0.25 0.8, that is we will clear the fault within 0.28 seconds and click OK, run transit stability, and then see the transit stability plots, and we will go to the buses and select the voltage, select these two buses, bus 7 and bus 8, and now you can see that our motors has been accelerated back to the original value. The voltage has regained to original value, that was the fault, but here it takes some 0. Around 3 seconds, 3 to 4 seconds. If your motor is suitable for that much time, they can work under load for 3 seconds or 4 seconds, then it is okay. For then your fault clearing time is this 0.28 seconds. But if you want to decrease this time, you can decrease by decreasing the fault clearing time. I will show you again. We will decrease further it, we will decrease it, we will take a 0.5, and okay, that is one. Now our fault clearing time is 0.250 seconds, and click OK, run transit stability, and run transit stability plots, and then buses, select the buses voltage and select all these buses and plot. Now you can see within 1.5 seconds our voltage has regained back. So that means our motors have accelerated successfully. This is the so our critical fault clearing time is 0.250 seconds. Now in the third lecture, in the next lecture, we will see that if we take the motors in a sequence wise, so that when fault occurs, after clearing the fault, we can start the motor 1 first, and then after some time we will start the motor 2nd, and we will see at that time what will happen at the 0.5 seconds of the 0.5 seconds of the fault clearing time, whether our motors get reaccelerated or not. Thank you.